Okay, here we have a group problem to solve. So I'm gonna show you the problem and give you some time to try to solve. So get pen and paper and try to solve this problem and then come back and look at the solution. So we have again a fixed point here, and then we have link AB that is rotating about A, and then we want to find the velocity of C. So we want to find the velocity of C when theta, which is this angle here, is 60 degrees, and phi, which is this angle here, is 45 degrees. So just pause the video at this point and try to solve the problem and then come back for the solution. Okay, by now you should have a solution, or at least you should have tried to solve the problem. So let's look at how to attack this problem. So the first thing is to find the velocity of B. So the velocity of B, this is a pure rotation. So this is omega r, right? Omega r. So then we can use this. And then we know the angle is 60 degrees. So we can find the position of B using that angle. So then this is omega, which is 60 radians per second in the k direction. So this is this thing here. This is RB relative to A vector. And so that gives me this vector here. So I have the velocity of B. So now I need to look at the velocity of C. And for that, I need to look at this as a translation plus a rotation. So I write my equation. The velocity of C, which is this point here, is equal to the velocity of B, which we calculated in the previous slide, plus the rotation of C relative to B, right? So rotation of this point relative to B. And that gives us a new angular velocity. This angular velocity is different from the one we had before. So always remember that. So now we can write VC, and we don't know VC, but we can write the vector in this direction, and we know that it only has a J direction because of the motion of the piston. So we know the velocity of B that we calculated before. We know this vector here is RC relative to B, right? So it's this vector that goes from here to here. And then we know that there's going to be an angular velocity of C relative to B. So now we can write this. We have this equation. This is actually two equations, one for the x and one for the y-axis. So we can solve for omega BC and BC. And when we do that, these are the values that you get.